Alrighty, folks, we are back for Inheritance and Solidity Part 2. Part 2. So in the last bit, we just talked about just to give us all a little quick refresher. Kind of the inheritance idea is we could build these contracts or these classes, if you will, and build on top of them. So again, we have this base contract, and then, forgive me, I'm gonna turn up the headphones for 1 second. But we have this base contract, this set of data, and then we can import that, we can inherit that set of data, and then build a second contract on top of that, kind of starting with that like template of data, if you will. And that's kind of where we get into the idea of like proxy contracts and a few other things. So let's continue our journey from inheritance part 1. So we were learning about virtual and override and just going through the whole thing. So let's just refresh. I think we actually ran through this bit. It was just going to the goal where we stopped. So let's refresh. So virtual and override. It's time to introduce new keywords, which is virtual and override. So sometimes we'll want to leave a function on a base contract open to reimplementation, which is when we would append that function with the virtual thing, the virtual keyword. And then moving forward, we would, if we wanted to change that function, we would then use the override function. So here we have virtual, then override. So for instance, if we're embellishing this hero contract, right, we can maybe make this a virtual, right? Oh, I can't edit this one. It's in read only. Interesting. Okay. Okay. So let's build. Maybe can I build? Okay. So let's just pretend we have this in a different file. This hero contract. So it's an abstract contract. So again, just bear with me because we're dealing with the read only deal, but another file, right? But effectively, this will work the same. So we have this virtual keyword that we want to append with, and then if we want to ever change that in one of these contracts that we're embellishing, we're building a mage class on top of this hero class, right? So the hero is kind of the more generic thing, and then the mage is more specifically built on top of the hero class. So now if I wanted to just specifically change the take damage for the mage, maybe the mages have like less shield or something, who knows, right? So then you could actually take this same function and instead of virtual, we could say override. This is my understanding of it. We can actually, maybe it's like instead of it just, normal damage, it's actually plus 10% damage, right? So that to me, obviously it's not going to work because we're importing hero from here, but I guess maybe this will let us run it. Let's see, contract warrior is hero. Can maybe just see if we can get this thing working just tentatively, right? I'll append it above, and let's see. Okay, so there's some issues here that probably need to get configured and fixed, but the idea is we can change things from this other file, right? From this we'll just flatten everything out from this other contract, right? So this other class, if you will. Let's keep moving forward. So in this case, both the derived and base definitions both have different functions bodies for the increased value. So here's our increased value function. You can see that the increased value is different on the base versus the override one. Okay, so the override function must have the same visibility as the function, as the virtual function. So they both need to be external functions or private or whatnot. Okay, so overriding function visibility differs. We talked about that error on the last one. We don't want that. Boom, boom, boom. I think we ran through some of the details on the nitty gritty, talking about abstract contracts. Okay, so we got to the goal. Let's get to this bit. So you'll notice that the hero.sol tab has changes once again. Let's look at these changes. This time there's 3 important things to notice. 1, the hero contract is an abstract contract. It has a virtual, I think that was very important. So we couldn't just modify a normal class. We have to have the abstract contract keyword there. So in this one, we are looking at this function attack, which is virtual. So it's just set up for us, but there's no actual logic with it. So an enum called attack types, here's our attack types. We can do a brawl or a spell, and they can differentiate between the attack types. And there's a contract called enemy. Let's take a look at enemy, which has a method called take attack. So it depends on the attack type that gets passed into the take attack. So we can see we have the brawl or the spell attack type. Great. So your job is to implement the attack function on the warrior and mage classes. So let's look at this. So here's our warrior class and our mage class. So more than likely what we want to do, I'm just going to copy this, steal this like this, and we'll say override. overrider. Here we go. Boom. So I think that'll do roughly. So add an override function called attack to both the warrior and mage class. So let's copy and paste this down. Seems like that'll work. How else can we see this? So I'm going to move my face. The function should take an enemy parameter, which will be an enemy contract. So do we need to import the enemy contract as well? Is the question, right? Contract enemy. I will see in a sec. So invoke take attack function on the enemy contract and change the parameter. So invoke the take attack function on the enemy contract and change the parameter based on the hero. So this tells me that we need to import the enemy contract. I'm not sure if we need to or not, but let's just go with the gut on this, right? So we need to import enemy soul. And in this, we have a take attack function, and it looks like we could pass in, or does the enemy, does this bit come from the, does it know automatically to import the enemy contract? So it looks like we should probably pass in some sort of take attack deal. And obviously for the warrior, we have a different set of tools. It should be the brawl attack type versus, let's see. Oh, this is where it's going to come from, or at least the attack type will come from here. So we have the enemy. I see. So it's already connected because the enemy is imported into the hero.soul. Okay. And then the enemy.soul is obviously this. So, okay, let's see. Did not mean to run the function quite yet. So we want to take the attack, but can I trigger this one is the question. I don't know if I think I need to actually import enemy if we want to trigger that. So take attack, and then I want to pass in with the brawl type, right? For the warrior, invoke the enemy's take attack with the brawl attack type. For the mage, do the opposite. So okay, let's try this. Let's import enemy then. Let's do it this way, and enemy. So take attack, and then the attack type is going to be one of these guys. So we have brawl for warrior and spell for the next one. Okay. I don't know if that's everything we need to do, but let's just let it rip, see what happens. Contract warrior is hero. Okay, so expected this, but got this. Oh, right there. Forgot a little deal there. So import this. Take attack was not from that. Interesting. So do I need to export it or something? How can I do this? So do I need to do enemy? Oh, you know what? If this is being passed like this, maybe that'll work. So we could just do enemy dot this. Brawl. Now, where do we get the attack type is the question. Enum here from hero.soul. We can't modify this, yeah. So, okay, so how do we import an enum, right? From hero.soul. Do I say hero.attack type.brawl? Kind of like this. Bet this one. So boom, we want the brawl, and then we'll take the spell. Let's try this. Let's try this, right? Yeah, we did it, guys. We did it. Nice. We're virtually unstoppable. Unstoppable, folks. Nice. That was awesome. That was super fun. Okay, so super call. In the last stage, we wrote an override function for an unimplemented function on the base contract. In other words, in other cases, the base contract will have functionality in its virtual functions that we want to share with our derived contract. That's when it's time to use the word super. So I don't understand that fully. Let's look at this example. So if the contract has a functionality in its virtual functions that we want to share with derived contracts, maybe not import them, we use this super deal. Is that what I'm seeing? So super. So let me adjust this or zoom out so the code's all organized proper. Okay, so we have a modified function in the base contract. We also have a modify function in the derived contract. So we say super.modify. Now, why? I don't understand that. So hold on. I'm gonna back it up. We're gonna beep, beep, beep. Back it up. So in other cases, the base contract will have functionality in its virtual functions that we want to share with our derived contracts when it's time to use them. Okay, so if this is, I see what's going on. Okay, so we still want to access this function right here, so the ×2 of the value. So it looks like this person is saying we're going to add 20 to the value, even though we're overriding the function, we're still going to use the traditional modify as well with the overridden bits of change data. Okay, so that's making sense now. So the original value is 10. We're going to add 20 to it. So now we're at 30. And then we're still going to trigger the old modify function 2 to multiply 32 so that we still get 60. Got it. So that's how to do it. Okay, so it's base modify would also work. Okay, so that's what we're doing, is basically calling the old deal. So we could just use the contract name modify or super dot modifies. I suppose it looks like they're both interchangeable. Okay, so I'm going to move my face a bit. I can cover up some of the goals. So you can see our derived contract. We are modifying the value and then calling the super dot modify to invoke the functions on the base contract as well. This will first perform the plus 20 value on the override function, then perform the times 2, which we just mentioned, from the super function, so resulting in 60. With arguments, this works like any other function we would pass through with arguments, like super dot modify. Okay, so if we were accepting arguments, I imagine we could just pass them right in. So the attack function is now implemented by the hero base contract. It will take the enemy as an argument and decrement energy from our hero after every attack. Let's invoke the base contract from the attack function for both derived contracts. Okay, so we have the attack function in our hero base. So here's our attack. So we could say super attack, right? I think that's what I wanted, right? Let's invoke this base contract function from within the attack function for both hero and derived attack. So we are doing that, I thought. The attack function is now implemented by the hero base contract. It will take the enemy as an argument. Oh, I need to pass in the enemy. Duh. How about now, Ron? How about now, Oh my gosh, this is too fun. Okay, so ownable. So base utility contract, it's often quite useful for a base contract to provide utility functions and modifiers. Let's see an example. So we have a contract, boom. Oh, interesting. So require deposit, and then we can use that same modifier in this contract because it's being built on top. So the modifier gets inherited automatically into here. So fun. Okay, so here the escrow contract requires the depositor to at least have 1 ether in order to deploy. Otherwise, the contract will revert. This requirement comes from the base depositable and is used in the require deposit constructor, or through the inherited requires deposit modifier, So that is cool. So on the collectible.sol, you'll see the collectible contract inherits from the ownable contract. So your goal is to fill out the ownable base contract, which is used by the collectible. So here's our collectible is ownable. We need to build a modifier, looks like, called only owner. So we'll add our magical underscore there. So the owner should be defined as the ownable. Ensure the mark. Well, hold on. Let's run through the goals. Okay, so step 1, your goal is to fill out the ownable base contract, which will be used by the collectible contract. The owner should be defined in the ownable base contract. So say maybe address, public owner. We can do this, and then we can set the owner to the msg.sender. So whoever sends the contract, they will be the owner. So that'll do roughly that, I think. I think that'll get her done. That'll get her done right there. So the owner should be defined in the base model or base ownable contract. So I think we've done that. Ensure that the mark price can only be called by the owner of the thing. So there it is, boom. So it can only be declared by the owner. I think we're there. I was about to say, get her done, A.A. Rogers. Okay, so call did not revert as expected. So what is going on? So the owner is being appended here. So on the collectible.sol, you'll need to see that the contract inherits from the ownable. It does. So base contracts we're pulling in the ownable is ownable from collectible. We have our modifier from here, only owner. Ensure mark price can only be called by the owner, the deployer, the collectible. This seems to be appropriate. Maybe it's just the public function. All right, we're going to take a peek, see at the answers. You don't got the answers, Sway. You don't got the answers. Oh, I needed to do a constructor within the ownable. Got it. Okay. Oh yeah, I missed a step in my brain. I forgot the bit of logic of setting the constructor to this, right? And then requiring that the owner equals the message sender. Boom. Okay, let's try that. Let's try that. Skip a step, skip a step, skip a step. My bad, folks. I don't got all the, I'm not Sway. I'm not Sway. I don't have all the answers. Okay. Okay, so we have multiple inheritance. Oh, that's fun. So we can do multiple inheritance. So we have contract derived as base 1 and base. So A and B is now accessible in the derived contract. That is super cool. Okay, so you can see, boom, here that we specify contracts that inherit from a comma-separated list. Here's our comma-separated list. The derived contract is inheriting from both base uno and base dos. When it comes to multiple inheritances, order does matter. Now, that is interesting. Now, why would order matter? Let's take a look. Let's take a look. So when inheriting from contracts, the most base contract should be the furthest left in the comma separated. The most base middle. Okay, now why? I imagine because how it's getting compiled is it's going to go left to right. So this contract's being constructed based on the lowest amount of functions in scope of variables and things like that. Then the compiler will move to the next bit. So if anything's reliant, if the middle contract is reliant on any of the base contracts, it needs to be compiled and processed first. That's my guesstimate. Let's read further. The important part here is that the top inherits from the base and middle in that order. Since middle inherits from base, this will not resolve the order. This will not resolve if the order was reversed. In this code stage, we can call that collectible inheriting from ownable and the transferable in this order. Based on the order, transferable can inherit from ownable, but not vice versa. In the code stage, it makes sense for transferable to. Okay. I don't know if they answered the question the way that I think I answered it. I think I answered it. Where you need the base one first because then the middle is going to be processed. I didn't know this, but I'm just saying I think the explanation could be conceded a little bit more. You are more than welcome to try this out. Try making your own ownable and transferable. The compiler will complain that it will be pretty with a pretty scary looking error. Linearization of inheritance graph is impossible. Basically saying, hey, I'm trying to do all the middle functionality here, but you're relying on the base contract functionality, so it's not going to work. It's impossible. It's impossible. So, okay, we're not going to read all this again. I think that just kind of convolutes it. But basically, if we had a function in this base contract that was like do math, right, or like a equals 1. But then in the middle contract, we had a function that was like function do math, and it was a plus b. We defined b in the middle contract, but we didn't define a. We inherited a. Again, yeah, if you're trying to, yeah. Yep. It all makes sense, folks. It all makes sense. So hopefully that makes sense, right? So maybe we can write that out. Maybe I'll make it a little bit more concise. So we'll steal this code. Contract is base. Contract middle is base. Contract's based, bro. All right, I'm sorry. I'm done. I'm done. Okay. So this is the lowermost contract, right? Ironically at the top of the screen, but it's the lowermost contract. So if we have it's right, uint public a, and let's just initialize it to the value of 1. And let's say we have a function here that is dependent on a, so some function. I was going to say do math, but we'll just say some function. And let's say this function says a plus equals 2. So it just adds simple function, just adds 1 to a. This order has to be this because it has to process this first before it can process this. It needs to know how a is being defined. If we do the inverse, so if I triggered the middle function first, it would say, who the fuck is a? Where did you get a? What do you mean? What are those? What are those? You know, so that's my understanding of it. So then if we want some function as well here, more math, right? Then we take, or I don't know, maybe if we want to do a virtual deal, so virtual, and then some function, override here, boom, and we'll actually make this one do 2, and maybe we'll do a super dot some function, right? So we obviously cannot process this at all, the top one, unless the middle one is processed. So order of operations, right? I don't know if hoisting works in contracts, but we'll pretend it's built like this, right? From the lowest bit of memory, we absolutely cannot get to this level of abstraction, right? However complicated the contract gets, we cannot get here if the middle one isn't built yet. And we can't get to the middle one if the base one isn't built yet. So that's all the order is saying, is we need to build the base, ignore all this code. We need to build the base before we build the middle, and then we can build the top. That's how I'm understanding that list order. Just because the compiler, it's going to compile here first, say, okay, let's define A initially. Okay, we defined A, got it. Now we can define the middle bit, some function, and then now we can do obviously our supers and all that stuff. So that's how I'm understanding the compiler here. I think when we get into the ownable, transferable, collectible contract, I think that's just an interesting way to go about it. I don't know, just a different angle, hot take it or leave it. Take it or leave it. That's how I'm understanding it. So, okay, so let's see what we need to do now. So the important part here, boom, boom, boom. Let's go back to our task. The collectible contract is now inheriting from the transferable. So we have collectible inheriting from transferable. And where's transferable? I think we need to make transferable. Okay, so your goal is to create a new transferable contract. So we'll do that. So contract transferable. That will allow the collectible to transfer ownership. Okay, so we have our ownable deal. And so we'll allow the collectible to transfer its ownership to another address. In the transferable contract, create a function called transfer, which takes an address for the new owner. Interesting. So we'll say funky town. So we want to transfer this thing. Okay, so have this function transfer ownership from the current owner to the new owner. All right, so we'll say new owner, we'll define that. And we'll say verbal. Need to make sure we do have the ownable on it. We'll have to check that in a moment. So I might need to add the modifier, but let's see. So new owner equals underscore address, boom. Okay, so in the transferable contract, create a function called transfer, boom, 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 boom. Let's take an address for the new owner. Have this function transfer ownership from the current owner. So with the new owner, oh, it's about address, right? With the new owner, just also, or the old owner, just be initialized as this. You know what? I think we could just do, yeah, just this, right? Don't even need all that. Okay. Ensure that this can only be called by the current owner. So if we do this, can I just pull this modifier from ownable like this or something? I don't know. We're going to have to see on this one. I don't know if modifiers can be accessed outside of scope like this. Now, where was this? Where's this issue? Source-based contracts, get this, but didn't get that. I see. Somehow we passed the compiler there. So public function transfer no visibility is instantiated. How about now? Owner is ownable. How about this? And we could do that now. How about them apples? Huh? How about them apples, huh? Guys, this has been awesome. We've completed the course. What a heck of a way to finish it. I had a hoot and holler. That was really fun learning about Solidity as a whole. I learned so many things. And I hope you guys have fun watching this. You know, it's been a fun series, and I'm actually bummed it's wrapping up. So, but there's more Web3 material that I'm learning and that I would love to share with you guys. So I'll probably do another series. They also have an EVM course, guys. I would 10 out of 10. 100 out of 10 recommend Alchemy University. They're just those kind of people who give out so much value and want nothing in return. So, you know, they're doing it for the right reasons and they're fantastic. And this is not a sponsor at all. I wish it was, but it's not. So yeah, so definitely run through their course. If not, just keep hanging around, you know, keep coming along with me. It's going to be a good old time anyways, you know? So you're welcome to, I invite you to join, to watch over here and enjoy the series with me, or at least the next series. So I am going to figure out the next plan on that, likely for the EVM and learning stuff around that. I'll give a quick glimpse of what we're building at work, which is some of this stuff. So this is where all this knowledge is also being just sharpened and honed in on. So here's like a treasury deal that we're working on that is just about fleshed out. what's my password here for MetaMask? Okay, so I have my dev account. Boom. So we have some coins. We have our tokens that we're staking. All the stuff. We have their staking mechanism working. We have our swap that I'm working on right now with the liquidity pools and a few things like this. So between the staking mechanism and the swap and the treasury, there's a lot of work to do, and there's a few other things with ERC 721 tokens that I'm working on as well. So it's really fun, like retrospectively understanding the roots, like really getting the granularities down, and then getting to take it to real life applications, because then you're building something really solid and robust. So that's why I'm doing all this learning, and especially going back and like filling in the gaps of things I don't know, because now when you take a approach like this, where you really crank on the fundamentals and have a good time learning them too, which is the fun part, you could build really robust things very quickly. So I just wanted to show that off to you guys, because it's something I'm really proud of, and I've worked tremendously hard on it, and the team is coming together to work tremendously hard on. So yeah, it's been a hoot and a holler, and we're obviously, and I'm obviously building from a place of wholesomeness and wanting to do it as proper as possible and filling in each one of those gaps. So yeah, I would push that onto you guys as well, is like, this is why you go through these series. This is why you take one brick at a time each day and stack it as good as you can, because by the time you go across 30 days or 60 days or however long it takes, or maybe even less, but when you really granularly understand, oh, this is how the memory gets stored on the contract, and it's pointing to this. When I'm mapping something, I'm making this bytecode point to this bytecode. And now you feel confident. Now you're like, when I'm navigating problems, I at least can understand the concept of how things are all pieced together. So it makes things so much easier and so much more fun. So I've enjoyed this series, guys, and I'm just basically saying, keep learning, keep on keeping on, folks. So obviously, if you've came this far, you're very much someone who learns. You're very much someone who learns. So I appreciate you for watching this far along and joining me on the journey. I'm looking forward to the next Web3 one.